OAB is a triangle, OA vector is A vector, OB vector is B vector, C is a midpoint of OA, D is the point on AB such that ratio AD to DB is 3:1, E is the point such that OB vector is 2 times B vector. Using a vector method, prove that the points CDE lie on the same straight line. So, it is given OAB is a triangle, so OA vector is just A vector, OB vector it's B vector, and C is a midpoint on OA, and BE is 2 times smaller than OB, or OB is 2 times larger or longer than BE. So BE looks like this, B vector, and since it's in the same direction as OB and is 2 times shorter, hence we can write that it's 0.5 multiplied by vector B. Same direction, but 2 times smaller. And also it is given point D on AB, so that ratio AD to DB is 3:1. And we need proof that CDE lie on the same line. How to show that 3 points lie on the same line? We should consider any 2 vectors constructed on any combinations between these 3 points. It may be CD and DE, or CE, DE, or CE, DE. Let's consider CD and DE. And if we show that one vector is some constant multiplied by another vector, it means that these vectors are collinear. It means that vectors lie on the same line or on the parallel lines. But since there is point D which is in common, hence these 2 vectors lie on the same line. So we can see that OC is 0.5a, CE it's also 0.5a because C it's midpoint. And what is AB vector? Because if we know AB, we can set AD and DB. We can apply a triangle rule for the sum. So if we consider AB vector, we move from A to B in any path. So AB vector is AO vector plus OB vector. And we can see that AO it's minus A plus OB plus B. And we can see that AD is 3 out of 4 parts. So AD vector is in the same direction as AB, but since ratio is 3:1, there are 4 parts in total, and AD has 3 parts. So AD is 3/4 of AB, hence it's 3/4 minus A plus B. And hence DB is 1/4 AB vector, which is 1/4 minus A plus B. Hence, we can write the CD vector and also apply a triangle rule for for the sum, we can move, for example, from C to D in this direction, so CD is CA plus AD, or in this direction it's CO plus OB plus BD, it doesn't matter. So CD is equal to, if we move through A, so it is equal to CA plus AD, which is equal to, what is CA? CA is 0.5A plus AD. AD is, let's open parentheses, it's minus 0.75A plus 0.75B, and we can add like terms, so it's negative 0.25A plus 0.75B. And let's consider DE, and let's find DE. So DE is equal to DB plus BE. Actually, we can apply always only triangle rule for the sum to represent any vector, because in general there is a parallelogram rule, and also there is a rule for difference, but it's always will be enough only triangle rule for a sum to get equation and solve and find the required vector. So DE is equal to DB, it's minus 0.25A plus 0.25B. What is BE? B is plus 0.5B. Hence, it's, we can see minus 0.25A plus 0.75B. Hence, we can see that CD is equal to 1 DE. When one vector is multiple of another vector, or it means some value multiplied by another vector, it means that vectors are collinear. And since there is one, it means that vectors are of the same length and are directed in the same direction. And hence they are equal. So we can conclude that CD and DE are collinear vectors. But it's not enough, because in general collinear vectors may be on parallel lines, but since D is in common, points C, D, E lie on the same line as required. And that's all for this question.